In this video, we're going to look at how to solve the same problems we solved using StatKey, but this time we're going to use the standard normal table. Alright, so in this first example, we have that IQ scores are normally distributed with a mean 100 and a standard deviation of 10. And we want to find the probability that a randomly selected person has an IQ greater than 113. So for all of these problems, the very first thing you're going to want to do is to draw your normal curve. So we're going to start with that. So we've got our normal curve. And we know that it is centered at 100. So we're going to put 100 here in the center. And we are interested in the probability that a randomly selected person has an IQ larger than 113. So 113 is larger than 100, so I'm going to put 113 down here. And I want the probability of someone having an IQ greater, so that means I'm going to shade the area under the curve to the right of 113. And the reason that I do that is this area, whatever this area is equal to, is the same as that probability that I want to find. Now, in order to use the standard normal table to find this area, the first thing we have to do is standardize the 113. So to do that, what we do is we say that z equals, so we're going to take 113, we're going to subtract off the mean of 100, and divide by the standard deviation of 10. And if you do that, that's equal to 1.30. And for all of these, you're going to want to take this out to 2 decimal places, and that's because if you remember, our standard normal table uses 2 decimal places. So let's look up this value, this 1.30, on our standard normal table. So here's our standard normal table. And remember the z that we're interested in, it's positive, so you're going to go to the second page. And just for convenience, let's write up here z equals 1.30. Now remember how to read this table is we look at the first 2 numbers, the 1.3, and we find them along the left. And then the last number, the 0, we're going to look at it along the top, and we find where they meet. So that is 0.9032. And what that tells us is that the area to the left of 1.3 is equal to 0.9032. So going back to the worksheet, what we're saying here is this area right here is equal to 0.9032, but that's not the area we want. The area we want is this piece right here. Well, that tells me that this area, since the total area under the curve is 1, this area has to be equal to 1 minus 0.9032. So in other words, the probability that a randomly selected IQ score is larger than 113 is going to be equal to 1 minus 0.9032. And so take a moment, put that in your calculator, and you'll find that that is equal to 0.0968. So, we can always write this in terms of the problem. In terms of the problem, this tells me the probability, if I could spell here today, that a randomly selected person has an IQ greater than 113 is approximately 9.7%, or you could have placed the decimal there. All right, so let's compare this with the answer that we got from StatKey. So if you go back a page, and if you look at what we had for that first problem on page 18, you'll see that we also found that that probability was about 0.97% or 0.097. So we get the same answer whether we use StatKey or we use the table. So let's look at another one. IQ scores are normally distributed with mean 100 and standard deviation of 10. What is the probability that a randomly selected person has an IQ smaller than 96? All right, so again, we're going to draw our picture. This normal is centered at 100, and we're interested in the value of 96, which is to the left of 100, and we want to know the probability of less than 96. So this is the area we want. So the first thing we have to do is standardize the value of 96. So we take the 96 minus the mean divided by the standard deviation. And if you put that in your calculator, you should find, oops, sorry here, I'm getting ahead of myself, that this is equal to negative 0.40. So again, we're going to go look at our normal table. So going back to the normal table, this time we have a negative value. So I'm going to erase some of this old stuff. And remember that the negative values are all on the first page. So we go to the first page, and just as a reminder, we're interested in z equals negative 0.40. So these first two numbers we're going to look up on the left side. So we've got negative 0.4, and then our number we're going to look at the top is the 0. We see where those match up, and we see those match up at 0.3446. So going back to the worksheet, what that tells me is this area right here is 0.3446. So the probability that an IQ is less than 96 is equal to 0.3446. Or we could say that the probability that a randomly selected person has an IQ less than 96 is about 34.5%. And again, if you go back and you look at our answer from StatKey, you'll see that we got the same answer. So let's look at another one. Again, we're still working with the IQ scores. We see they're distributed normally, or normally distributed with mean 100 and standard deviation of 10. And we want the probability that a randomly selected person has an IQ between 112 and 125. So let's draw our picture. Again, we know the IQ scores are centered at 100. Now I've got two values I'm interested in. Notice that they are both above 100. So I've got 112 and 125. And then I'm interested in the area between those two. Okay, so here's my area in between. So what I'm going to do is now I have to standardize both of these values. So I'm going to call the first one ZL because it's the lower of the two values. ZL is going to be equal to 112 minus 100 divided by 10, which is going to be equal to 1.2. And then I'm going to have a Z upper, which is the top one, or part of the upper one, the 125. Is going to be 125 minus 100 divided by 10, which is equal to 2.5. All right, pardon me. So now we've got two numbers that we need to look up on our Z-score table. And just for completeness there, we want to take those to two decimal places. So let's go back to our Z-score table and see what we can find out. All right, so first of all, we're going to look up that lower one. So remember it was positive and all the positive values are on the second page. So we've got Z lower is equal to 1.20. So looking up 1.2 along the left and 0 along the top, we see that the area to the left of 1.2 is 0.8849. So what that tells me is the area to the left of 1.2 is, let's just go back and check that number again, we've got 0.8849. So this area is 0.8849. Now let's look up 2.5. So again, now we're looking at Z upper, which is equal to 2.50. So we look up the 2.5. Here's our 0, so we get 0.9938. So that tells me that all of this area is equal to 0.9938. And again, that was all of this area. So notice if I take the 0.993, sorry, let me double check that number here. That should be an 8. Fix that. If I take the 0.9938 area, which is all of this, and subtract off the 0.8849 area, I'm left with the piece that I want. So what that tells me is that the probability, remember that we're interested in IQ scores between 125 and 112, well, that's going to be equal to 0.9938 minus 0.8849. And again, take a moment and put that in your calculator. .1089. And if you go back and look at what we found in StatKey, you'll see that we found almost the exact same thing. And then to complete the answer, you would want to write a sentence similar to this one up here. All right, let's look at a different type of problem in this one. This one says IQ scores are distributed with mean 100 and standard deviation 10. Under what value do 80% of IQ scores fall? So again, we're going to draw our normal. It's centered at 100, but this time we're not given an end point, we're given an area. So we want to find under what value do 80% of IQ scores fall. So in other words, we're looking for a value down here on the x-axis so that we have 80% of the area to the left of it. Well, we know that 50% of the area is to the right of 100. So if I draw a line here and I say that this area is 0.8, I'm looking for this number that's down here. So how can I find that? Well, we're going to start out by finding the z-score that corresponds to an area of 80. So going to our table, remember that all of the middle values, so I'm going to erase this old work here, all of the middle values of the table, so in other words, all of these numbers in here represent the area to the left of some point. So we're going to find the area that is closest to 80. So notice 80% is somewhere in between these two numbers, and it is closest to this one right here. So the z that we're going to use comes from here and here. So in other words, z equals 0.84. So going back to our worksheet, we know that when z is equal to 0.84, that we have 80% of the area to the left of z. So we can set up our formula that we have. And actually, if you go back and you look, pardon me here, if you look on page 19 of your notes, we have this formula where x, the value we're interested in down here, is equal to mu plus z times sigma. So the x that we want is going to be equal to 100 plus the z that has 80% to the left of it times our sigma. So if you put that in your calculator, you'll find that the x that we're interested in is equal to 108.4. And that's the exact same answer that we got using StatKey. So to get the last answer, I'm going to let you try that one on your own, but it's going to be a very similar process to what we did here. You're going to use the same formula, and you should find that you'll get the same answer that we did on StatKey on page 18.